All right, so tonight there'll be two assignments from today. Okay, one, there's going to be that Desmos thing where you had some of the different activities. You had to click through the slides. There's going to be one that has 3 slides of that. It's going to be graphing situations. Okay, one is like a Ferris wheel, one is go-karts, one some dude getting shot out of a cannon. Okay, so what you have to do in that is you have to draw the lines that go with it. Okay, and what you'll see is whenever you draw a line, there's going to be a solid man. So I'll use, for instance, the guy getting shot out of a cannon. It's going to look something like this overall. It looks like something like this overall. Okay, and what's going to happen, wherever you draw a line, there's going to be a solid man that follows that pattern. All right, the correct answer is going to be like a shadow of a man. So you have to draw it so they both match up the whole time. All right, that's how it's going to work. So I'll put that one up. That'll be one. It'll be a little bit more from lesson 1, and there'll be some stuff from lesson 2. So lesson 2, we got patterns and linear functions. I am recording that right now, right? I did start it. Yep, we're good. All right, so patterns and linear functions. We're going to go through this one. We're going to hit this whole thing. There'll be some work on this as well. So patterns and linear functions. First off, we have a couple words. We have a dependent variable. It's in a relationship. This variable changes in response to the other variable. So you're going to have 2 variables now. You have y and x most times. Dependent variable, it changes in response to the other variable. This is typically your y value. Independent variable, it does not change regardless of the other value. This is the one that you would plug in. Most times this is going to be your x. You have inputs into your function. Your inputs is typically your x value. Outputs are typically your y value. Okay, so those are just a couple things. So you've heard them, and we can go on to take a minute. If you're writing it down, take a minute, go ahead and write those down. Out of coffee, not good. Yeah, we're good. Got it clean. I put a lot. My house still smells like French fries, but we're good. All right, we good? Johnson, you know, second. You good? You good? Okay. So the next thing we have, maybe frozen. All right, a function. A function is relationship with exactly one input for each output, and a linear function is a function when you graph it, it is a non-vertical line. Okay, so essentially, for lack of a better way to put it, is if you have inputs go into this function over here, outputs are going to be paired. Okay, so for instance, if your function says y equals 2x, okay, and I put in a 3 for x, well, 3 times 2 is going to be what? 6. So I'm going to get out that 3 is going to be paired with 6. Okay? We'll do a bunch of those. Don't worry. Don't freak out. We'll get to those. That's called an input-output table. We'll do those here in 2 slides. All right? But again, a function is just some relationship with exactly one input for each output that it's going to relate something over time. It's going to relate something based on a situation, those types of things. We'll do an example with a word problem here next. You ready? You're still writing. All right, so evaluating the function. We got Juan. So Juan begins walking from his friend's house, which is 50 meters from his own house. Function d equals 3t plus 50 gives the distance d in meters after t seconds that Juan is from his own house. Find the output d for the input t equals 10. All right, so that sounds like a lot, right? All right, so I'm just going to copy down the function. And I'm actually going to make this y and x just to make it look better for us. Is that all right? I'm going to make it y equals 3x plus 50. All right, it's the meters that he is from his own house after however many times. Okay, so for instance, if I'm walking this direction and I have a function saying how far I am away from, say that table is it. Say each one of these blocks is a foot. Okay, so I'm walking away 1, 2, 3, 4, 5. All right, so 5 seconds. So each one's a foot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in 5 seconds, I walk 12 feet. Okay? Does that make sense? Relating two things. Seconds, distance. That's what this guy's doing. Okay? He's walking at this thing here is saying what kind of speed he's walking at. All right? So then if I want to find out how far he went in 10 seconds. T is 10. How far did he walk in 10 seconds? All I have to do, that's my input, I put it in for x. So I have 3 times 10 plus 50. What's 3 times 10? 30. 30 plus 50 is 80. So after, in 10 seconds, he went, how far? 80 meters. Okay, does that make sense? Okay, that just represents how far he's going over time, that function. All right, in 10 seconds, he went 80 meters. All right, what about 15 seconds? Well, if I want to find 15 seconds, I'm going to say 3 times 15 plus 50. What's 3 times 15? 45. 45 plus 50 is 95. Good. So in 15 seconds, he went 95 meters. What do you think I have to do differently for 30 seconds? Plug in a, yeah, exactly. Plug in a 30. Y equals 3 times 30. What's 3 times 30? 90. What's 90 plus 50? 140. So what does the 140 mean for us? Distance. That was meters. How long did it take him to walk that far? 30 seconds. There in 30 seconds, he went 140 meters. So it's going to be a consistent speed throughout. It's relating how far he walked in X amount of time. Okay? Make sense? So that was one put into words. Let's even step back and make it a little bit easier. So this is something called an input-output table. All right? This is mostly what it looks like as an input-output table. I make it a little bit bigger. I like to put a second section or a third section in the middle. All right, so we have a function y equals negative 2x plus 4, and we're going to have the inputs of negative 2, negative 1, 0, 1, and 2. So we want to find out what value we get as an output for each one of these inputs. Okay? Now the reason I don't like this chart on the left is because there's nowhere to put your work. All right, I like to put this one here so you can put your work. So I already have the inputs listed. This guy here on the top is my function. So let's do this one together, and then I'm going to have you do one on your own. All right, so what I'm going to do, I'm going to copy this function down to the top line. All right, negative 2x plus 4. Now, what we are doing each time, my input is my x, so my y is kind of irrelevant in the equation. All right, so my y is kind of irrelevant in the equation. I just have to plug a negative 2 in for x and simplify, just like I did in the last problem. Whatever I get in the end, that's my y value. Do it again with negative 1, and so on. So let's do the first one. I have, again, like I said, this is kind of irrelevant here. So I have negative 2. I put a negative 2 in for x plus 4. What's negative 2 times negative 2? How about positive 4? So then I have positive 4 plus positive 4. What's 4 plus 4? 8. There's no negative. Next one, put in a -1. So I have -2 times -1 plus 4. What's -2 times -1? +2. 2 plus 4 is 6. That's my output. Good. Keep going. -2 times 0. What's -2 times 0? Someone better not say negative. It's 0. Anything times 0 is 0. So 0 plus 4 is what? 4. There is a 0. A 0 cannot be negative, first off. Anything times 0 is 0, and 0 plus anything is whatever you added to it. All right, let's keep going. Well, I still have some sanity. It's a -2 times 1 plus 4. So what's -2 times 1? -2, thank you. So a -2 plus 4. Don't say -6. 2. Do I need to play the video? Same sides add, different signs subtract. Same sign, keep the sign different, keep the larger, you know? Last one. -2 times 2 plus 4. What's -2 times 2? Thank you. What's -4 plus 4? And it's not -8. 0. All right. So these are my inputs. These are my outputs. If I plug each one of those values in, I get one out. So just like I said before, every time I put one number in, what do I get out? One number out, right? And they're all paired together. Okay? And if you look at it, there's a pattern. All right? These ones are increasing by 1 the whole time, right? What are these guys increasing by? 2. Or they're decreasing by 2, right? There's a pattern. A function is a pattern. A linear function is a pattern of some sort. Remember we did patterns before? No. We talked about those? Okay? That is why we do this. This is why we evaluate. Evaluate patterns. Guess what? Functions. Right there, baby. All right? Questions on that first one? You all right with that? All right. You did. This should be review. Okay. Now, here's one here. It's a little bit of a story to it. All right, but it says the function t equals 1/2 m minus 12 represents the temperature T in a container in degrees Celsius m minutes before and at the start and during an experiment. So complete the table below. All right, it is still just x and y. It says t and m, but it's still x and y. So I'm going to help you get started. This is t equals 1/2 m minus 12. If you want to make it a decimal, make it 0.5, that's fine. Use a calculator, that's fine. But I'm going to give you about 5 minutes, and I want you guys to complete that table.